In this section, we will look at how to simplify our circuits. Now let's see how to simplify a circuit. Let's first look at this example. Looks very complicated. We will go step by step, use the rules, laws we learned to simplify it. So this is the original problem. Let's start. First, let's use De Morgan's law. Review De Morgan's law is break the line, change the sign. Look at here, here's a line over here. We can break this line and change the sign from and to or, like this. And then, don't forget, if you have two lines above it, one line means not. So not is actually a yes. That is called the double complement rule. So if you have not, basically you can delete it. Next step, distributive law. By using distributive law, first look at the first two parentheses. Use FOIL, you can FOIL it to be 4 terms. And then from here to here, that is called the inverse law. Y and Y not is always equal to 0. That makes sense because think about if Y is 1, then Y not is 0. If you have a 0 in an AND logic, you must got a 0. Or if Y is 0, then Y not must be 1. So same thing. And next step, any value or a 0 is any value itself. So this 0 gone. And the next step you will see a variable and itself is still itself. So that's why we can get to here, X out in this section. So if you consider those two terms, factor X out, first term left a Y not, or second term left a Y, then you can get to here. And then don't forget a variable and it's not all together. What you got? You always got 1. And then next step, a variable and 1 is always a variable itself. Then don't forget variable or itself is still itself. And then distributive law again. X and X not must be 0. And 0 or anything is just that thing. So finally, you got this. Compare this. So we simplified this complicated circuits to just an X and Z. Sometimes we need to consider the complement of function, because sometimes it is more economical to build a circuit using the complement of a circuit, of finding the complement of a Boolean equation. We'll see an example. First, let's review De Morgan's law. Break the line, change the sign. Break the line, change the sign. And De Morgan's law can be extended to any numbers of variables, not necessarily 2. It could be 3, 4, whatever. And now, for example, let's find the complement of this function. So to find the complement, you put a line above its function. So that's why on the right side, you put a long line over here. And using De Morgan's law, don't forget, you can break the line over here, change the sign. So that's why you go to here, and you can continue. For each line, you break the line, change the sign, break the line, change the sign. In this case, actually you have not, so that's why it's X itself. Similar thing here, if you break the line, then you have not above the Z, so that's why it's just Z itself.